Okay, so some of you looked at a poster called How Tall is Tall. I should stop and say that the topics that were chosen here were not chosen based on any particular continuous theme. Each one of the elements has been mapped to science, math, and reading standards in the schools, but the actual concepts were just fun science concepts that came off of the top of my head. And this one, this How Tall is Tall, is based on the simple question that I think young kids would be enamored with, which is how tall is the tallest mountain? And those of you who looked at it saw that the points made here are, first of all, that although we live on what appears to be a very rocky, mountainous planet, in reality, it's not so uneven compared to the size of the planet. So if this was the Earth right here, these little ripples on the basketball are about the size of the tallest mountains. So for the most part, we live on a very, very spherical, flat surface. And yet, in reality, when we go and move around the surface, we find lots of tall mountains. So how do you figure out which is the tallest? And it's a good question because you need to establish how to make that measurement in order to answer it. And making measurements and understanding that they are often relative measurements is an important thing for students to be introduced to, and it's not hard for them to then quickly figure out how that becomes important. So if you look at Mount Everest, if you ask yourself what the highest mountain is above sea level, you'll find that it's Mount Everest. But Mauna Kea in Hawaii it's 14,000 feet above sea level, but its base is at the ocean floor. So from base to top, it is the tallest mountain on the planet. However, Mount Chimborazo in Ecuador, being on the equator of a planet that's spinning around, and as a result bulging out at the equator, the planet is a bit oblate. Now, we tend to think of that as meaning it's almost an oval. It's not exactly an oval. Again, if this was the Earth, it's thicker at the equator by about the width of a dime. Okay, but if you scale it up, that's a lot of kilometers on the full mountain, on the full planet. And so this mountain here, being on the equator, has a head start. If you ask which mountain peak is farthest from the center of the Earth, it's neither of these. It's this one here. And then we make the point that it really doesn't compare at all to the largest mountain in the solar system, which is on Mars. As you saw, we have questions that are at different levels that go with each poster. And on this one, some of the simplest ones would be, where would you find the base of Mauna Kea? That's a statement in the poster itself that it is on the bottom of the ocean. And it goes up to higher levels, which are off the page here.